Apologies for being a little bit late. I was typing these up until the very bitter end. Again, thank you to everybody who submitted questions. I kind of lost count, honestly. It was somewhere between 10 and 20, I think, and they're all really good questions. And so I made some slides to step through and hopefully help a little bit. Okay, how many participants do we have? 50 or so. Okay, on this slide, I just wanted to emphasize, I think I have not been very clear about the very last point here at the bottom, that the final exam will be open book and open note. You, of course, don't want to be digging through your notes, searching for minutiae or, you know, I mean, the worst part is if you're digging through your notes looking for big concepts because you maybe haven't attended the course or something like that. You don't want to be in that situation, but it's fine to be open book, open note. And boy, I think I keep biffing this. I probably should have said open internet too. You're welcome to check the internet for stuff. The one thing, and this will be clear on the exam itself, is that we're going to ask you to adhere to the honor code and not collaborate on the final exam with other people or other pets or other creatures. That's the one rule here. Are there any questions about the final exam format or timing? Question, is it going to be multiple choice? Yes, I think there might be some other types of questions. There might be, I think, multiple answer, which is sometimes viewed as differently, right? You know, those are sometimes the really tough ones where sometimes you can have multiple right answers. And I think where possible, I like multiple choice a little bit better because I think it hurts your brain a little bit less. Yeah, the check all that apply is what I mean by multiple answer. And so we might have a few of those, but I think I'm writing the exam, the GSIs are writing the exam, we're all collaborating on it right now. And I think we're headed toward more of a multiple choice kind of thing where there's usually one right answer. Well, we'll be clear, of course, about the rules for each of the questions. What percentage of the final will be from the first half of the class and what percentage from the second half? The way I like to answer this is not quite with the precision that you've got there, but more like to say that small details from the first half will definitely not be on the final exam. You might see some details from the second half. The stuff about immigration, the fiscal impacts, I think, if people are confused about that, but I'm not looking at, tiny details, but, from the first half of the course, the big picture stories are what you will see, the solo model, the saving rate and how that contributes to capital, the Malthusian model. Those are the things you'll see from the first half. What is the overall grade needed to receive a pass for this class? It's a C- with fudge. Well, I saw a directive from Berkeley Central about that even if you get what would have been a D, so we didn't give any Ds at midterm. I don't intend to in the final exam. But even if I were to give a D, the directive was to carefully consider whether that maybe is a passing grade. So I think there's a good chance you're going to pass the class if you take the final exam and if you took the midterm and if you completed the lab. So if you participate, you will most likely pass the course. What percent would be a C? Well, we curve it. So the curve is the median grade is a B or so, a B plus. And so if you're in the lower, if you're below the 50th percentile, you're in the B to B minus range. And if you're down at the bottom, the 28%, that's going to be the sort of C range. For the curve, the pass not pass students will be included as well. Correct. That's correct. So it means that you're competing, if you are electing to choose a grade, you're competing against everybody. They will all be given a grade, and then the P not P students will see that grade turned into a P or not P. And again, I don't think anybody's going to not P the course. That's an awful way of saying it. I don't think anybody's going to not pass the course. I don't think. As long as you do the exams and do the projects, the labs. We don't have a class project. I kind of wish we did in a way, but then it would make a huge burden on the grading at this point. Grades will be assigned, including all students. You could say it that way. It means that everybody has if you like, a phantom grade in the background, and then it gets translated into a pass or a not pass for the students for whom they're going to choose the default of pass, not pass, which I highly recommend. I think it takes the the concern away, because there's way too much to be concerned about these days than your grades. The grades, that's what I have to say about the grades. Other questions about the final? Whenever I think of PNP, it's a computer science thing about the scale of like solvable problems, P equals NP or something like that. I don't even remember. I'm not a computer scientist. Does the final replace the midterm grade? I'm not sure what that means. Sorry. Final and midterm are different. Okay. The midterm is still part of your grade. Thank you, Leslie. That's right. Okay, shall we move on and talk about the questions? I can hear typing, by the way, if other people can as well. Folks might want to check their mics. It's okay to, to include the typing sound, but it is a little funny.
Oh, sorry, it's me.
No worries. I feel like I'm in an office or something. And I guess it adds a little bit to the sense of community, which is sometimes hard to feel. It's just me and my fig plant otherwise. Okay. All right. So I'm going to see if I can, maybe I'll try to keep the chat window open here somewhere because the chat's sort of important today. Feel free to raise your hand, of course, if something isn't clear, if you want to, if a question you see is one that you had, or if you had a question that was similar, but it wasn't quite phrased this way, feel free to raise your hand or put in the chat or something like that, whatever you like. Okay, the first question, and I was warm to my heart because this poor student was on the other side of the earth and said, you know, I can't make the review session. Are you going to record it? And the answer is yes. So we are recording as I speak. The big question is whether DSP will be so kind. They have just been fantastic. They have closed captioned everything since class 13 or 14, I think, which is just a monumental task, and they have done it. So I don't know about that, but we will have a video and post it. So if you are overseas and it's 0 a.m., go ahead and tune out. We will have this recorded for you. I feel so bad for everybody having to just upend their lives. I have no idea what I would have done had the pandemic hit back when I was in college. It's I mean, I guess the thing is that, there is more flexibility sometimes when you're younger, but it's still a huge imposition. And I feel like I'm really pretty lucky in the larger scheme of things. On to the questions. So please review income and substitution effects. These are hard, and I haven't actually shown any of the pictures in these slides because we can do that if there's time. I'm not sure it's helpful to show the pictures anymore. And you can look back at the videos where I was showing the pictures and step through them and maybe have a more specific question about it. And so we'll get to some of this later. And there was some confusion, I think, especially on the 2019 final exam, which really confused me as well. And the 2019 exam was written by different folks. And so we'll get to that in a minute. The income and substitution effects are hard. I mean, what you need to know about these is that they are generally present when you have a budget constraint and in a difference curve kind of setup going on, and you're talking about optimal choices. And it could be relevant at a time. We had a part of the class that was all about optimal saving and pensions. It could be relevant in that case, but the most direct course material in which it's relevant is the value of time model of fertility. And the problem there is that it can get dicey, but the biggest story is that the wage earned by females is part of the price of childbearing because they disproportionately bear the time costs, if you will, of raising children. It's not always that way in all households, of course, and it also doesn't have to be, but it, practically speaking, is and has been in the empirical record throughout history. So that's the big deal there. So the thing about a wage change for females, if suppose the female is currently working, then if her wage rises, that produces more income. That then leads to an income effect. And that should increase the purchases of all goods. So children are goods, popcorn is a good, movies are goods in normal times. I guess we can only watch Netflix, of course. So if that's the only part of the story, then you would expect for an increase in female wage to raise demand for everything. But the problem is that the substitution effect you'll see, a rising wage will shift you away from children. because children cost time. And when the wage is the price of time, that part has risen, then the price of children has risen. And here, when I've described it in this particular slide here, it's a story about the budget constraint from your perspective, I think, like that, if I get that right. It's rising with the female wage rising, but pivoting, right? So it's becoming steeper. And the problem with that is that in the case of childbearing, if that's a problem, maybe it isn't, it moves you along the difference curve that way. So that's the substitution effect. And those are the sorts of things that are very much, you know, they're going to be on the exam for sure. And they're hard. It's hard to get used to that. So I'm going to go ahead and plow through. Go ahead and try to send a quick chat. I've got that the chat open, or raise your hand if something isn't clear. So this, another one, I think from the same student, perhaps. Please clarify immigration theory versus empirical data and impact on natives. If you're confused about this, it's because theory will usually give you some pretty clear predictions. And then it turns out that empirical data really often doesn't give us particularly clear predictions, or it gives us predictions that maybe don't really fit particularly well with the theoretical models. And so I think that's what the student was kind of getting at here. So I wanted to write a few things, and I'll just say it. The theory, of course, it depends on whether you're talking about a model in which capital and other things can adjust, like the Solow model, or if you're talking about a model in which you've got a static or fixed labor demand curve, and the results are different theoretically, depending on which of those two worlds you're looking at. So if you don't model capital adjusting, then labor demand slopes down, immigration reduces wages, period. If you do model capital, then over time, labor demand will probably shift out as capital adjusts to meet a larger pool of labor, and maybe there's no effect of immigration on anything. It also depends too about how you model immigrants, and that was part of, I think, a very clever set of questions on the spring 2019 final exam about PhD immigrants who were immigrating. If you model immigrants as being high-skilled PhD holders, then probably the outcomes are going to be a bit different than what we saw in the class slides, where we started from the, I mean, why do we do it this way? The politics of immigration in the United States usually are about low-wage workers, often from Mexico, but sometimes, you know, it kind of dips into the refugee issue and all that. And so that's why the focus has traditionally been on what the story is in the labor market for low-skilled native workers who you would think compete with these folks. And that's been the case for the last, I don't know, 100 years or more or something. Okay, so the theoretical story depends on which model you're talking about here. Yes, so I'm just seeing a private question here in all history. Yes, that's correct. If students want their questions to be private, that's fine, and I guess I'll say yes or no, and then I'll leave it at that. If you want me to talk about it all, please list a public question so everybody can see it. With the empirical, okay, here's a public question. What happens to wages if the immigrants are highly skilled? Well, it depends what you're thinking about here, but I guess I'm inclined to believe that, you know, the basic downward sloping labor demand model with highly skilled immigrants is unlikely to be what you want to use. In principle, you would think, though, and I mean, you know, I don't know if the grad students feel this way or not, but of course the grad students, so I'm native born, but several of the grad students are foreign born, I think. Right, but do we PhD holders view our wages as being negatively hit by the presence of foreign born labor? I think most of us would say we don't. It's not clear. Anyway, so I think you might have to just toss out the model entirely. I think the 2019 exam question, we'll have to look at it, I guess, as to how we modeled labor there. I mean, it just depends what you specify, and then a good exam question would try to be careful about this. Can you please review immigration of skilled versus unskilled and impacts on skilled and unskilled natives? That's a very big question, and I think what Nicole's getting at there in the chat is probably Well, I'm not sure, to be honest. It's a broad question. I think maybe I better keep going with what I wanted to say here on this slide, then we could circle back if you wanted to refine the question a little bit more. I guess I'm not entirely sure what you mean about which part. So let me just say, so the challenge here is that the empirical literature is technically mixed, but generally it says that you know, the basic static model of labor demand seems to be incorrect. There seems to be very small or zero impacts on native wages or unemployment, which is surprising, but it might be because capital is actually rather quickly adjusting. That's one way of saying it. And it could be, so we talked about the Bracero program and the ending of that around the Kennedy and Johnson years, which is 1964, roughly, something like that. The story there that emerged was one of mechanization, so that the removed, or, you know, I'm not sure they were forcibly removed, but the Braceros who were asked not to come and they weren't given work visas anymore, so they went back to Mexico. That absence of labor then resulted in farms, mostly in California we're talking about, but other places as well. They just mechanized. They didn't hire native-born laborers, that maybe they felt that the native-born wouldn't actually take the jobs. And so if you look at this, at the time series, you don't see any effect at all on wages or employment of native workers in those skill areas, which is surprising. So it depends what you're talking about, theory versus empirical. You see different things, and, you know, what's the real science? Well, it's got to be the empirical stuff at the end of the day. I mean, none of us live in a textbook, right? We all live in the real world. So it's true that we have theories, they tell us certain things, but you have to subject them to the data. And bottom line, it appears that, from my perspective anyway, the empirical record really seems to suggest that there's basically zero impact of immigration on things that like wages that you might think normally it would have impacted. Okay, so here's a question again about the theoretical model. I'm confused about how the net impact on GDP from lecture 20 is calculated. Can you go over another example? This is in reference to the slide on have things changed since 1997. I'm not quite sure how the last bullet point was calculated. So here, the first thing I've got in blue right here is the actual bullet point in question. And maybe let me start at the end. If you actually just multiply all these numbers through, what you see is 0.3% or 0.0033. So I guess I dropped off the 3 in the last 3 and I rounded it there. It's a small amount of total impact on GDP associated with a very large amount of unskilled native immigration, and this is in the theoretical model. Okay, this is tricky, and probably the trickiest part is where, and I'll break it down for a second here, where this 0.05 comes from. The rest of it is half base times height. So it's the area of a triangle. And the problem then is that, okay, that's the GDP in the particular labor market we're talking about. It's the total output, if you like, within that part of the economy. But then the problem is that it's only 0.5 of the total economy, which may surprise you, but, you know, that's maybe the very good fact, I suppose, that you know, agriculture is where a lot of this is happening, and it's a pretty small part really of the total national GDP. So here I think I diagrammed out just where these things are coming from in case you're interested. And this might show up on the exam, but if it does, I try to also show you the picture of it here. And the story is that you've got a downward sloping labor demand curve and a labor supply curve that's basically vertical. If the thing shifts out, what you would see is a small triangle down here, and we're calculating the area of this thing. It's 1/2 the base times the height. And I've put in some more labels here about what these things are. And these might be different depending on when you're measuring all this. And so one of the things that changed was the share of GDP in this particular market that's produced by unskilled workers. It actually fell in the time period, so between 1998 and I guess it was about 2014 or 2015 when I wrote the new slide. The other thing that was different too was the native-born share of people without a high school degree. And I think I'm implying here that was only 33% of that labor force, which was, you know, largely shrunk then. And so 66%, or 2/3 roughly, was foreign-born. So if you run this weird thought experiment about, suppose all those workers were gone, what would you see happen? And it's not a big change in total GDP. In this model, of course, you would see a pretty big change. It's this change in the wage. You would see a pretty big change for the wages of those who with less than a high school degree. And I guess if I could just speak sort of extemporaneously here, one of the things you could say here, which I think is very salient, pertinent, and just relevant, right? Those are all synonyms. I'll try to say fewer words. It's hard when you're speaking into a Zoom void. Okay. A change in the wage here of this is 20%, I think, if I'm reading this right. If you believe that that's actually true, is a big deal for less than high school workers in the United States who are native born. Where else do we see something like that in the class? So here in immigration, but also at the very end of the course when we were talking about health and the case in Deaton, deaths of despair. So it's relevant, and I guess maybe it's almost unfortunate that studies seem not to be able to really measure this happening. So George Borjas has some stuff that we had not looked at, but he usually focuses on African Americans with less than a high school degree and suggests that their wages had really been hit a bunch by immigrant workers arriving and competing and all that. But of course, the big story in case in Deaton is not at all the African American workers who appear with their mortality to be benefiting relative to where they had been. It's about white non-Hispanics, and so it would be, if you felt that in fact those folks competed with immigrant labor, say in California, it would be exactly those people. So that would be, I haven't written the question that looks like this, but that would be something that might be fair game on the final exams, to try to connect those dots and say, well, is it plausible that immigration is part of the story of deaths of despair? And I think one would probably say, probably not, at least in the empirical record. Okay. Moving ahead, so again, just try to flag me down if you want me to kind of go into greater detail here. Here's another question altogether off. So our midterm this year, and this arose actually independently in office hours a little while ago, that a different student had exactly the same question. And I'll make this bigger in a second. So the question is, how does population affect the MP, the marginal product, and the average product curves in this, I think in the C175 model? The student is having trouble conceptualizing this question in general. Let me now make this bigger. So in office hours, I came to understand that the answer and the question could have been written with a little bit more detail and specificity here, especially in question 6, I think. We always do the best we can, but sometimes the questions are written with not all the words that they should have been written with. So let me get to that in a second. But the basic story is, especially in 6, we're asking students to kind of do a detective novel in some sense, to tell them what had happened to wages. I think that was something I wish I had written out here. And then back out what must have occurred to, the big shift in labor supply. So question 6 then states that we must be in a position where to raise consumption back to subsistence level. And there you have to recognize that what we're talking about is the difference between subsistence consumption and the prevailing wage. So the implication here of this part in question 6 is that we're at a level of population where the vertical labor supply curve intersects the marginal product curve at some level of the wage then that results that's below subsistence. It must be here, but we still have a feasible plan of taxing land, which is the other factor of production. It's where the rest of the money must be going. If it's feasible to tax land and redistribute, then you also know that it must be the case we're somewhere to the left of 04. If we were to the right of 04, the jig is up, the game is over. Everybody's, well, not everybody, but a bunch of people will die unless they immigrate and cross the Atlantic or whatever it is, because only to the left of here, where an average product, or if you like, food per person, is going to be in sufficient quantities so that a redistribution could actually raise everybody back above subsistence. So it's a detective story, and yeah, I regret how it maybe was not as super clear as all that. What I thought the question was about, and this I don't think was quite hitting the nail on the head, at least not in office hours. I thought the question was more about a change in population does what here? And the answer is population is the horizontal variable. So a change in population will be a movement along any of these curves. You could think of a vertical labor supply curve in intersecting average product and marginal product in particular spots and telling you what the GDP per capita, that would be average product, or what the wage, which is the marginal product, what those would happen to be for a particular level of population. Okay, moving ahead. Okay, final exam on last spring, immigration, section number 4. Not sure if I missed it, but I don't remember a lecture on odds ratios or, sorry, my screen is blocking that. Odds ratios or substitutes and complement goods in this context. These are really good questions. Let me just say that. The second one here was related. Let's have a walkthrough of the immigration question in last year's final, number 3, how to approach these problems and how to interpret that graph. Okay, so these are really great questions. And this exam question, I imagine, probably took students out of their sort of, comfort zones because it combines a couple of different topics in 175. But it also, if you look at especially question number 4, I think it set the table in a fairly reasonable way by explaining something. So the odds ratio, for example, and that, odds ratios are a little weird to me as well. But if we'll look at the question text in a second, I think it was a reasonable way of setting it up. Some things are hard to explain, and I think could have been explained better, just like the previous example. I wish I had written it a little bit better, and this same is true here. And so anyway, we'll step through it. So these sorts of things are, likely to be confusing, but ultimately what we're trying to do in 175 is to show you course material and have you absorb it in a way that will allow you to take pieces and recombine them if you need to. That's kind of one of the big things about a liberal arts education. We're not teaching you skills that are particularly useful in any context unless you became a professor and taught 175 yourself, right? But what we're hoping to do here is to be able to spark the synapses and all that, and to have you think about connecting ideas in some way that makes sense. And so that's kind of the way this exam question went. Let's go ahead and have a look at it here. The other thing I noticed is that the answer key had in red, I think, the answer that was a little flexible about how this was going to be graded, and I suspect perhaps we didn't maybe put finishing touches on the answer key, and that that happens. It's hard to kind of dot all your I's and cross all your T's. What we've got is the basic 2-country immigration setup, and so let me just walk through what's happening here. So the basic story then, as we saw in class, and it was in Michael Clemens's first, I think, article on the reading list. You got these 2 countries, one's on the left and one's on the right, which is a little different, but it's the basic idea is that there's 2 labor demand curves. And the movement of labor supply between them then is going to, if you removed all restrictions, actually equilibrate the wages across these 2 countries in principle. So here's where these 2 labor demand curves intersect. We're struggling here with the fact all these lines and curves are actually black, which is unfortunate. So that would be where we'd end up, that there'd be a big movement into this richer country too, which has this labor demand curve that's higher, presumably because technology and capital are higher there. And a poorer country 1 that's sending immigrants from originally L0, they've got a lot of labor and they're sending immigrants here. Okay, I struggled myself with, well, where do immigrants show up? And I think in this question, we're still going to assume that they're these people who are along the horizontal axis. But the additional twist here, of course, is that they have PhDs, right? So that's the first part of this question. You learn the immigration law is only relaxed to allow for more PhD educated mechanical engineers from country one. So this, this happens in the real world. And, I mean, from rich countries' perspectives, wouldn't it be nice to just feast on the highly educated labor coming out of developing countries? And this is typically called brain drain. It's great if you're the receiving country, you get the highly educated mechanical engineer. You didn't spend any public money educating that person, and that person came. Okay, and this does happen, and some immigration systems, of course, are set up to try to do this sort of thing. Traditionally in the United States, we have not had a system that has solely done this, with some caveats, of course, about the H-1B program, which often does target individuals like this. So part of the challenge I had when reading this is it depends what assumptions you make about where these immigrants will show up. If they have PhDs, then traditionally we don't really treat them as just bodies that move across borders in their labor. We're usually thinking about these people as being highly skilled, and also skilled in coming up with new skills and new technologies. So here in the second sentence, because of technology and capital levels in the country too, the grammar's a little interesting there, but so be it. That's the receiving country. The engineers were able to use their expertise in self-driving cars to begin manufacturing cars. For the car company Lesla, which I just thought was great, and it made me wonder who wrote the exam question, or whether it was a teasing thing. Anyway, did you guys see, actually, so Elon Musk and his girlfriend had a child, and they named the child a name that does not seem to be pronounceable. They announced it on like Instagram or something. It's so funny. All right, before we crack more jokes, I better look at this chat, because it looks like folks are raising questions about this. Why is labor demand for country two upward sloping? It isn't. Country two is over here on the right-hand side. That's the hard thing to get your head around, right? That they are flipped, just like Matthew's pointing out. That's right. Tracy's got the child of Elon Musk, and I can't remember I wish I did, his partner's name. Okay, labor moves in opposite directions toward each other. Yes. And then finally, Emma's pointing out, apparently it means Kyle. A funny way of spelling Kyle, isn't it? Okay. All right, focus. Focus, Edwards, focus. Okay. That's the biggest problem in this model, is to get your head around how there's one labor supply curve, which is a very elegant way of doing it. But then there are actually two labor demand curves, and one of them has the opposite slope from what you're usually thinking about, because they are measured from the other origin there. That's right. So I think what this question was trying to get at was how able to use their expertise in self-driving cars to manufacture them at a huge scale. I think that's telling us about a productivity increase. And that's plausible if you're thinking about immigrants who have PhDs. I promise that if we write an exam question that kind of looks like this, we will write it with the clarity that we would need to actually draw out that kind of answer, that we're looking for a shift in the labor demand curve, and it's in the receiving country because they've absorbed the PhDs and presumably have become more productive. So I think that's what that was about. But to be honest, I had a tough time myself about it. It's hard. Exam questions are hard, and we're going to try to make exam questions that are a little bit more transparent. I do this all the time, and I always try to improve the way I write exam questions. Everybody does, and this one was a little bit unclear to me. The next part was, I think, a little bit more clear, but also pretty challenging. Okay, so here's a question from Samira. Does it mean that we treat immigrants with high skill the same as immigrants with low skills? Can we say, in this case, unskilled native labor benefit? The two things that you've stated there, I think, are a little different in my head. I think, right, so high skill immigrants, PhD immigrants, if they arrive, they're going to benefit naturally the complementary or sort of opposite factors of production, like low-skill natives. So that would be my inclination to view that high-skill immigrants, basically, I think we ought to model them as shifting out the labor demand curve. Either they're increasing technology, or basically they are those factors of production that are then in larger supply. They shift out the labor demand curve for low-skill workers of any variety. And so the exam question here then, assumes that there is no increase in low-skill workers due to immigration. I hope that was clear. Trying to, keep your apples and oranges straight. If you're talking about, PhD immigrants, those are different than if you're talking about low-skill immigrants. Here's a question: don't the plants require unskilled labor only, while only PhDs are allowed in? I think I put an extra word in there. Sorry about that. I think what that question is getting at is how I think unskilled labor is complementary in production. You need to have unskilled labor along with the PhD immigrants. And so that fits a story in which what happens when PhD immigrants arrive is they shift out labor demand. They are these other factors of production. They shift out labor demand for unskilled immigrants, raising their wages, other things equal. So Arya's question: would the low-skilled workers be better off with the immigration of high-skilled PhD workers? And the answer is, I think, yes. Here's Chris's question: wouldn't mean that allowing the PhDs in requires an increase in unskilled immigrants, since the question says plants need new workers? Yes, I think that's right. Yes, yeah. I think I think we've managed to get our heads around this one, but it took me a while, and I think you have helped me understand what the point of the question was a little bit better too. Okay, so the other twist here, of course, was adding in this marriage market part, which was likely to do folks' heads in and maybe make them a bit nervous, but the hope is, again, that you'd be able to combine some of these different disparate parts of the course into something that made some sense if the application called for it. Okay, so we're using this measure, this odds ratio thing, and I'm still not myself all that sold on it. And I doubt, let me put it this way: I have not yet written an exam question for this year that has the term odds ratio in it, but suppose I did. I don't think I will, but it was explained at least in the introduction. And so that's what we'll do. So the odds ratio can take values from 0 to positive infinity. You guys saw this in the lab, of course, but it might be hard to remember. And then the salient point is that the higher the value, the stronger the positive sorting relationship of likes attracted to likes. So the question did a very nice job of saying, well, here's this measure, here's what it means, and now please use it and think about what's going on. So using that introduction, then, we're seeing that before the immigration wave, this odds ratio was 10, it was large. After the immigration wave, it was 5, it had fallen. And so it means that you've got a less strong positive association of PhDs linking up with other PhDs, that you must see in some greater shares now, PhDs marrying people who didn't have PhDs, right? So different groups, whatever you want to sort of illustrate that with your waving, flapping hands like I am doing in a silly fashion here. Okay, and then which of these questions, would be the correct, would be correct sort of takes on this? So answer A, immigrants are marrying only other immigrants, doesn't seem right, because if that were true, then more PhD immigrants, so all the immigrants have PhDs. So if A is right, then we should have seen an increase in this metric, and we didn't. We saw a reduction because they only have PhDs. So if they're only marrying other immigrants, it's only going to strengthen that connection between PhDs. B is kind of like a mirror image of that. Immigrants are marrying natives. We know, of course, that not all natives have PhDs. It's sort of the top of the educational spectrum. You can't go any further than that. I guess you don't even have to know that part. You just have to know that there's other classes of education in the native group. And so that one could have been the story. So B could have been the story here. So C and D are a little challenging because of these terms substitutes and complements. And so C, education is a substitute good in marriage for the immigrants. And what we mean by that is that the traits that, and here we're talking about immigrants, are looking for, the traits that immigrants are looking for include some set, and there's some substitutability between the education trait and some other trait we haven't specified, meaning that the people will be willing to choose somebody who doesn't have a PhD, doesn't have this level of education, but they have something else. So that's what that is trying to explain, and it's, the language is a little bit tough, to get through there, but that's the idea. And so that would also be reasonable, that education has some kind of substitute out there in terms of a trait. If it didn't, then you maybe would not have seen this reduction in the matches of likes to likes within PhDs. Answer D, before the immigration wave, education was a complementary good in marriage for the native population. And I think the idea there, complementary, meaning that, yeah, it's hard to, what one is thinking about here becomes rather complicated, because it's education is complementary, meaning you need to have it to go with other things. Yeah, I struggle with using substitutes and complements in this sense, because what you're really talking about here is the two different levels of education within the two different partners in the marriage, and that gets more complicated than just thinking about, say, within one person, a complementary situation between education and some other good or something like that. So what it's trying to get at is this notion of going together or not going together. And this, I think, then is also a pretty reasonable explanation, that education was something that was viewed as a complement across these spouses. You'd want to have them together, and that you couldn't substitute for that particularly well. And so that's why you saw a higher odds ratio before immigration. Okay, so that's what I've got to say. Let me see what the questions that are coming in here. So Justin is saying, we're trying to say that native PhDs tend to marry others with PhDs before the wave. Yes, and so it's also a story about, not just the natives, but also now afterward the immigrants. It's sort of, everybody in the country, how strong is that association of PhDs with PhDs? And the answer is it weakened. So it must have been the case that immigrants coming in ended up marrying folks without PhDs, because all the immigrants had PhDs. Here's Kavina's question. Sorry if I did pronounce her name correctly. Is the odds ratio essentially the probability of the event happening? In this case, the odds ratio for PhDs decreases, so the probability of it goes down. Yes, I think you could view it that way. It's a little different. I'm trying to remember how this all works, but I think I better just stick with what the exam says. I'm not a sociologist, and I don't use odds ratios that much. I'm an economist, and I like probabilities, and there's I guess a monotonic mapping between them, but I'm reluctant to get into details other than to say that I think your intuition is correct. And hopefully maybe the GSIs can weigh in on that, or Piazza or something, and get the story straight if I've made a mistake here. Here's a question from Justin. Since the odds ratio is much higher, as in you need the PhD to be a viable marriage candidate, it's not, you need the PhD to be a viable marriage candidate to another PhD. It's a story about the assortative mating between different people, and we're saying that, here's the PhD on the one partner, here's another potential partner, and that, we're blocking up like that. We're not getting like a that or something else. So it's the positive association, that we see, suggesting that somehow this is great to combine PhDs with PhDs. And yeah, just step back and let's think about this a little bit. Is that really the way things go? And there are a ton of things you could say about that in modern living, especially now that we're all on video conference. There's a benefit to having two people with high skill, degrees who are able to say we're both work at home on video conference in these days. So that's the way to kind of think about it. Okay. Okay. Substitute good. here's the question, and again, I think it's better if the question is public, if it can be, but I understand. Maybe I'll stop saying people's names. I don't know what I'll do. Okay, what a substitute good in this question means, and I'm kind of struggling with that myself, but it's in a marriage market, what is a substitute good? We're talking about traits. And so, when people are trying to form a marriage, they think about the traits among people in the marriage market whom they might marry. And if a trait has some substitute, it's a statement that, you could take that person with the trait that you're looking for, or you could take a person with a different trait. There's a substitute there. That's what that's trying to get at. Okay. Okay, good. I think these are good remarks here in the comments. Okay. And so I think maybe we should move on. So we've got about 35 minutes left, and let's see, we're almost about halfway through the slide, so I think we better move ahead. Okay. So the cost of time model, and this is getting into the income and substitution effects. Let's see, I'm trying to get the question out here so I can read it. I know we have covered income and substitution effects multiple times, but it's still not making sense conceptually when talking about births. Yeah, I sympathize because, one of the big problems is that when talking about births, what's the price of a birth or a price of a child? And I think the main point there to make is that the subtle part of the price is the wage that you have to forego. It takes time to raise kids, and you can't, as every parent knows, you can't give all your time back to the labor market unless you've got this amazing, I don't know, grandmother who lives with you or something like that, takes care of the kids. But you can't spend your time in the labor market earning and taking care of your kids. So the wage is a really big part of this. That I think will help get you through this, that it's a story about the female wage. If the female wage rises, that gives the household more income provided that she's working, but it also raises the price of children because it's an opportunity cost. Okay, so in this question, the number one in the fertility sequence last time, my guess was that the substitution effect was dominant because his wages increased, and that's what I would have thought too, and we'll see this in a second. People substitute away from births and work more, and that is not the correct answer. Yeah. So I think perhaps it was the wrong one that was shaded in red there, and I apologize for that. I had looked at it and I thought it was right, and I was like, oh, I don't know about this one, and then we went, I went ahead and pushed it out, and I think maybe I should have edited it, and I apologize for that. So again, income effects, the story is, if you have more income, you demand more of everything, and that should be true for children and popcorn and movies and all that. With the substitution effect, you demand less of the good whose price has risen, which is the number of children, and females' wages have risen. I think part of the problem with this, which is, I think this what the student was referring to, it's the question doesn't say anything specifically about female wages, even though we know that in fact they're doing something in the background. So it's a tough one. I guess I think answer B is better for me, and I think that's what the student said here. I like answer B better. I'm not sure why answer A is there, that if an income effect in fertility choice would imply that you buy more of all goods, which children are goods. Now, it's also true that quality is a good. Education for the children is also a good, and maybe that was what was happening here. But the question sets up the cost of time, or synonymous with value of time model. So I guess I think that B is a better answer here. But I'm open to other other discussion of this. Here's a question from okay, several here. For substitution effects, why do people demand fewer kids when wages rise? And then the follow-up is, does that mean foregone wages? Is that how the price rising is measured? That's exactly right, and it's a very subtle point. that yes, that the price of children includes the actual monetary price, the cash that you pay for their clothes. They go through clothes like you wouldn't believe. The cash you pay, for their food and their schooling, to shelter them, all that. But it's also the foregone wages. And I admit, maybe something that people are struggling with is how, it's also true that you can have a child and, have a grandmother, you could maybe have a grandfather, I don't know, but it's usually grandmothers who are better at this. Or you could have a nanny who could be a male or female or what have you. And that's true, but the process of bearing the child, and if you don't bear the child, of course, the process of adoption is a very, very lengthy and time-consuming process, and it means you can't do other things with your time. And so that's what this is all about, the value of time. If the value of time, the wage, is higher, that will produce this substitution effect away from having more children. And the Becker model, of course, with quality tossed in there, basically says that the substitution effect is even stronger. It's amplified in this fashion. You get this extra substitution effect toward away from child quantity and toward quality, and that's triggered by all these sorts of things. Okay, because the price of kids has risen, so you substitute away from kids, you demand fewer. That's right. That's the big story here. Yeah. Okay, when does Becker say substitution effect is amplified? I don't know. That's what I say. It's in the reading, I think, that got posted by Tim Ganane. That was not, I think, on the reading list per se. Becker's stuff is, and this actually came up in office hours, I think, on Tuesday, especially like Becker's stuff on assortative mating is like seriously hardcore stuff. And it's hard to find these parsimonious statements about this in Becker's actual texts. Just to make this point very clear, everybody, do not read the Becker readings as you study for the final exam. Under no circumstances should you read the readings to study, because they're not parsimonious. They're very technical and brilliant, but they are not good things for review. Could the nanny theory explain why China was able to support families with more children despite lower wages? I don't quite follow. Sorry, it's a great question. I'm not really sure. Okay, so maybe we'll move on. Okay, here now is going back in time to the 2016 exam, which I think I've got on the next slide. And I think the student was a little confused about the way the model showed up in the 2016 exam. It's because the math was a little bit more complicated with more things floating around. And the other thing that I insisted on back in 2016 was to produce this kink in the budget constraint, which happens when this is relevant, that you can max out your time on kids and be totally out of the labor market when this is happening, when you've got NMAX kids, which is the total time that you have divided by the per child time cost. So the total time you have is uppercase T. And I hope somebody will flag me down if I'm missing something subtle about the notation that we changed to. I think this is still always what we do. We write uppercase T as the total time endowment, like it's 24 hours a day, or you could scale it in some other ways. And then little t is the per child time cost. So if you divide your total time across all your children, you don't have any time left for sleeping, I guess, if you're doing a 24-hour day, which is actually, as parents in the audience will agree, is actually kind of the story. When you first have children, there actually is no time to sleep ever, because the little buggers have to eat like every 3 hours. It's just insane. So you're taking 24 hours and dividing it by a number like say 3 hours per child. And so you get 8 children, I guess, if you maxed out. So that was the number of the number of children that you get. Yeah, it's true. The amount, and that's the thing about nannies, is like nannies will help you, grandmothers will help you, but nobody can do what you must do if you actually deliver a child. And this is especially true for the female, but it's also true for the partner. Uh, there's just a lot of doing that goes into it all. Oh, Thunderdome, I love it. Oh, I will tell you, it gets easier with the second child, and it's because it has to. It has to get easier because you've already got the first child. There's no way that it can be just as hard as it was with the first child. Okay, so let's quickly look at the math, I guess. We're doing pretty good now. I think in terms of time, we've got 25 minutes left. So this was the more complicated model that showed up in that final exam. And in particular, I think oh, I see. Well, one way in which it's more complicated was I was introducing this extra parvidol. Suppose we thought about the consumption that was, so there's little x, which is the variable. It's the confusing thing. Along the vertical axis is the quantity of adult units consumed by the female, meaning that's what she actually can consume. And then there's also a little y, which is, and with the chromosome X and Y, of course, I guess that makes sense to some extent. That's the quantity of adult units that's consumed by the male. And the point was then to set up this, you know, it's an augmentation of the standard model, and to think a little bit about what happens if the male ends up being a net drain on financial resources of the household. And so that's on the next page here. On this page, I'm trying to remember what we're doing here. I think we've got the same budget constraint that we're accustomed to. The money income is equal to the total amount that the man pulls in, uppercase Y, plus the wage that the female faces times the time that she is spending in the labor market, assuming that, you know, she's got this time endowment, uppercase T, and then she's subtracting off N, which is the number of children, times little t, which is the per child time cost. And so the difference then is the amount of time that she spends in the labor market. And then N max then is what you get if you take your total amount of time and split it across children rather than spending any of that time in the labor market. Yeah, a lot of things. I think I had at least, you know, there was an even earlier, more awful version of this model that also included a price of the consumption goods by adults, and that was just a real mess. At least we've gotten rid of that. The answer seems simplified. Why not use the equation set t is equal to 0? Well, that's a good question. What would it mean though to set uppercase T equal to 0? That's the total available time. And so I think what we're struggling with perhaps is what are we indexing with what here? That's the total time you have in a day. And so setting T is equal to 0 is sort of equivalent to saying that the woman is dead, right? Or something, I don't know. I mean, you don't have any time left over. The challenge, I guess, is to remember that, you know, so you've got 24 hours of total time, uppercase T. The amount that you spend on your working is a time that's measured by T minus little n times little t. And so here, suppose you've got 2 kids and they each cost you 3 hours per kid. That's 2 times 3, which is 6. And then uppercase T is 24. So you've got 24 minus 6, or 18 hours to play with. And we're working the whole time. So maybe we want to reindex this to, I don't know, 10 or 12 or something. I don't know how many waking hours you've got, maybe 14, no, 16, right? That would be if you get 8 hours of sleep. Doesn't the question say the woman runs out of time? That's right, but what does that mean? It means she exhausts all of what uppercase T is across the children, meaning that N is a number that when multiplied with little t gets you T minus N times T equal to 0. And that's then what you got here. So maybe another way of stating this is to use the equation. Well, which equation do we use? Well, it's this one. So we're setting this T minus NT, uppercase T minus little n times little t, equal to 0, and then solve for n. And then you find this. T minus NT equals 0 means she has no free time. She has no time supplied to the market, technically. I think in the models, the woman never has free time. The time either goes into children or into working. And of course, technically the male has no free time either, I guess. The male just works all the time. So Arya is saying, I think the question is trying to specify that she won't run out of money to have as many kids that she uses all her time to have kids. That's quite right. That it's trying to set up how you've got this income from the male that's going to push you up from your perspective here and give you this kink in the budget constraint. That's when she's maxed out her time, and that's the maximum number of kids. She's not pulling, she's maxed out on time. There's no time to give into the labor market, and that's why this kink looks like the way it does. Couldn't you say each child past the first has a lower marginal time cost, so Nmax is more dependent on income? I'm not sure about the last sentence, but yes, the first part of that, couldn't you say each child past the first has a lower marginal time cost? And that's quite right. But everybody is going to agree with me, right? That this model and the Becker model are already super complicated. So Richard's point is exactly right. It's just that injecting this realism there is going to create additional problems. And I'm trying to think how to think about that. I'm not sure what it would do exactly, but it would change the budget constraint in a way that I haven't really thought about. And if we were to inflict that on you on the final exam, which we haven't written a question that looks like that, we would allow enough time for you to actually get past it. That would be tough. It probably wouldn't be linear anymore, because as the number of kids rises, you're seeing the time costs per child fall. I don't know what that would look like. Okay, and Sakshi's asking, so all the time spent on kids is the location of the kink. That's right. All the women's time spent on kids is that kink. That's right. She's out of the labor force. She's spending all her time on kids, no time in the labor market. Okay. All right. And here on the next slide, I'm going to show the questions related to this. The fertility quantity quality model number 1, why is D true? And number 2, why is the money cost of each child different? The equations in this model make it seem like they are fixed because there is a fixed value for P. Okay. All right, so now, sorry, having read that, here's another question in the chat. Doesn't that have less to do with maxing out her time and more with how the male's income covers the household expenses? I guess I don't follow, but the facts that you are stating here are true. When the woman has maxed out her time on child care, they've reached maximum fertility, she is not working, and that means that the male's income has to cover the money expenses, the household expenses, which includes her consumption, his consumption, and also the money spent on the children too. That's always the thing that gets a little dicey. So if you think, what is on the vertical axis of the kink? What's the height of that? And the answer is it's the man's income, but then minus all the cash that is spent on the children. And then what is left over then is the cash that can be consumed by the husband and the wife, basically as household consumption. Okay. All right, so quantity quality model, okay. Yeah, and this is challenging. So here's the question then from the 2019 final. And what we've done is the quantity quality model where, okay, and this I think showed up in the slides this year, and it confused everybody because it's a confusing thing. There's a total cost of children that equals the number of children times some kind of, say, bed cost or something. It's a fixed per child, fixed per child cost. I'm sorry, I got confused by where the comma was there. So you think of this as like the space or the meals that you need per child. And then there's some kind of pay to play quality cost. And that's, I think, pretty confusing. It's, I'm trying to think of what that is exactly. What's a good example of that? I'm not even sure. It's a flat cost that might have some changing price associated with it for getting any child quality. In other words, education. You could think of it, I guess, as living near other people, so you can actually go to school, right? That there is a school. You have to live in an urban area. I'm don't, but you could think of it as transport costs, maybe, to get the kid to and from school, perhaps. You might, I guess, think of it as like a homeschooling cost if you did it that way. The idea is that it doesn't depend on the number of kids that you got. And what would it have to be? It would have to be something like the cost of walking the kids to school. And it doesn't matter how many kids you have. You could have 10, you could have 1 kid. You have to spend time and money getting them to school. Yeah, it's a public good for children. That's kind of the way to think about it here. And I don't have a good example in mind, but I've tried to. Anyway, so the thing, though, that really is operative is this last part. And this is the part that's probably most familiar. It's that there's a quality unit in here, a variable, the quality of per child. It's like the number of years of education you've got. Time, that's the little q, times n, which is the number of kids you've got. So if you send them all to college, you have to spend that for each child. And then there's a price of college then, that's PC, that then multiplies that whole thing. So that's the total price of quality then is this pay to play term, like walking them to school. It doesn't matter how many you have, but it's also the thing that varies with the number of kids that you have. Okay. 1D then. Which the following is true about this model? And the question that the student had was, why is D true? The costs per unit of child quality are fixed. Is that true or false? And the answer is yes, that's true. So this is a correct answer there. Yeah, I'm trying to mind meld with the folks who wrote the exam here, and it's a parameter in the model. It shows up as this thing that's right there. It's the cost per unit of child quality, and then it's fixed because it's a parameter. I mean, that's one way of viewing it there. So I sympathize with the student who asked the question because it's kind of making my head swim a little bit. How could that not ever be true? How could it be false? Maybe that's what the student was getting at. Okay, and then here's a question. Could I explain each of the choices? Yes, let's do that. So let's look at A. The consumer maximizes utility subject to a nonlinear budget constraint. So the first part is probably a little clearer. Maximizes utility, and that's, well, there's a utility function, and it's U is a function of X, all their consumption goods, little n, which is the number of kids, and Q, which is the quality per kid. Yeah, somehow you're better off if your children have this average quality level. Okay, so answer A is true because the budget constraint is non-linear. Why? So what's a linear budget constraint? It's something that has prices times quantities. And here we've got a price times a quality times a quantity, or if you like, a price times a variable times a variable. And that's the nonlinear part, which, so knowing it's nonlinear may be a little bit hard to get one's head around, but hopefully we talked about it enough during class that maybe it's a little bit more obvious. Okay, so answer B, children who receive more education give their parents more utility. That's a little hard to answer. If there's a utility function that's specified right here, look at the arguments of the utility function. And that's the mathiness of Econ basically. So Q is in there. That's the more education is child quality, and it results in more utility for parents. Answer C, cost per quality input, PQ are fixed. So encyclopedias, okay, so I should have read further down. So that was this example of the public good, right? I guess it would have to be like an online encyclopedia that each kid could actually access with his or her tablet or something, right? Because if you have a paper encyclopedia, it's clear that 2 kids are probably going to fight over it. Okay, that's also true. Just by assumption, these are sort of fixed parameters. Okay. Yes, and so Arya's writing, the quality is, say, the total money income divided by number of kids times the price of these. I think it's technically the quality units. And that was the sort of the simplified version of this, where what we're doing is getting rid of the first 2 terms and having just the 3rd term still in there. Okay. How are we doing for time? So we've got 10 minutes left. We've got, oh, I should probably keep going here. Looks like we do have several more questions. I was too optimistic earlier for covering all these. The good news is the slides are there, and we can continue the discussion if we don't finish it. Okay. Using the notation above, write an expression for the cost of an additional child. So the cost of an additional child is the is the direct cost per child, and then plus the cost of the quality units. If you're comfortable with calculus, you can think of this as the first derivative with respect to n of this budget constraint that's back here. So let me, in the interest of time, let me kind of keep moving ahead. Okay, and this is a little tough to look at here, in the quality quantity model, which I think we just looked at, what is the difference between PQ times Q and PC times Q times N? The answer is encyclopedias. That's the PQ times Q. You've gotten these, maybe it's the, you know what that is, maybe it's the online membership and like whatever, online university or something. If you just have a fixed cost of actually sending the kids to online university, which of course works so well when you have kids, it's pretty silly, really. The PC times Q times N is the total cost of quality spread across the N children. Okay, so I think we covered this. Okay, all right. So here were some really neat questions about immigrants and capital. First question: can we assume that immigrants never bring capital with them? And my answer was, well, probably, because physically bringing physical capital is not very easy. Immigrants could bring money, which you could think of as capital, and money and capital sometimes are synonyms. And you could view it that way. It's hard to imagine them actually bringing, the office buildings and the computers. The computers maybe somewhat, but the construction equipment and all that stuff that is actually physical capital. So if they bring money, maybe what they would do is effectively raise the national saving rate, at least in the short run. You could view it that way. It usually takes time to produce capital. We try to be clear about this on an exam about whether they do or don't bring capital and what that really means. If immigrants did bring capital, how would this affect the Solo model? That's the second part of the question. So usually immigrants are labor. If they did bring capital in, for example, if they brought it in the same proportion as had existed, then you wouldn't see any change in any way. You would in the Solo diagram, you'd end up with the same level of capital per worker because the new immigrants just brought the same amount per person that had previously existed. So it depends. Last question here: is it possible for immigrants to have an immediate short-run positive gain to capital per worker? And probably not if you're talking about capital per worker in particular. And the reason is, capital is not easy to transport, and you probably wouldn't want to. It's probably in place. But I think we saw in class that you could imagine a scenario where immigrants bring technology, and that would raise output per worker immediately and saving per worker, which would raise, the first thing raises incomes, and the second one, I guess, also consumption as well. So there are ways in which stuff could actually improve in the short run. It just depends on the assumptions. Okay. I think in the interest of time, I better charge ahead. I see there's a question about the quantity quality. Maybe we can handle that offline. How math heavy will our final be? Heavy math. Sorry, I couldn't resist. It's a really good question, though. How much math? Are we expected to be able to calculate things? If so, what should we practice? You should know the symbolic math of the Solo model, but don't kill yourself working through the formulas and solving for K-star. I don't think that'll be on the final exam. And if we change our minds, we'll send out a notice about how you might want to look at that more closely. The math of measures, and here what is it math? You need to know what these measures are and what they mean. And so the differences between period and cohort measures and you know, what it means to measure fertility and life expectancy, what those happen to be in broad terms. You don't have to know the specific gory details, but you know, period means that you're measuring things in a time period, and it means that you've got a bunch of different birth cohorts, people of all different ages, and you're looking at the rates appropriate for all those very different people at a point in time. And that's true for fertility and also mortality or life expectancy. And you will see a different thing if you look at the cohort measure, which is going to tell you something about the actual life experiences of people. Okay, can you please explain the curve and grading again? I think in the interest of time, I think I better not. I'd be happy to answer over email. Okay, I'm confused about the role of land in the Malthus model and how does it affect the graphs and curves. So land is like capital in the SOLA model. If, and it's hard to imagine how this would occur, but if land were to increase or decrease, it would shift labor demand either outward if you increased land or inward if you decreased land somehow. And then the other question is, what happens to the Malthus model with increases of the variable factor of labor? What happens to the graph? So labor is population. That's, I think, true in all the models that we consider, that if you're alive, you are working, which of course is not quite true. But and so technically in the Malthusian model, the extra thing that's happening here is that population is actually determined by the birth and the death rates. So you'll see an increase in population if births exceed deaths, and a reduction if the reverse is true. But if you're thinking about a shock to population, you know, it could be like a war kills a bunch of people or something else, or a big addition to the population through immigration, that would be a one-time shock, either up or down to the level of population, and that would show up as a movement along the labor demand or the marginal product labor curve. Okay, so we're almost to the end here. And can I repeat the difference between cohort and period? Let me just quickly say that then again. A cohort measure is a measure across actual people over their whole lifetimes. So a cohort fertility measure means the number of children that say I will ever have. And you know, I'm 46, and so the book isn't going to be closed on me until I'm somewhere in, I don't know, 90s or 80s, wherever it is that you lose fertility. You can make a forecast of that, but the problem is that you don't know for sure until everything's over and done with and somebody's dead, basically. So period measures are more commonly used, and they're very informative, but what they do is they mush a bunch of people together in one time period. It's you know, you, it's me, it's our parents and grandparents, everybody measured, and then the vital rates associated with whether it happens to be like fertility or the rate of death or something. And then what you do is you come up with the index that tells you what's happening right now, but it's to a whole bunch of different people. And you can have different experiences then for cohorts or for individuals. Okay. All right, so I just had to laugh that this was kind of a funny question that I wrote, getting back again to the value of time. And I didn't quite understand the sort of the punchline of the question here. So women, the answer is all, you know, it's this issue about suppose the male brings in less than he's absorbing basically from the household. And what I was trying to get at was this issue of maybe, you know, here's an economic model of not being married if the male isn't sort of pulling his weight, especially if he requires time from the female. So that's the idea there in the second bullet. The second question, what does it mean that the man consumes the woman's time? It means that not only does she have to spend time on children, she also has to spend time on him. And you know, that might be a plausible way of looking at it. Maybe that it was all set out in the question, and it leads you in this direction of thinking, well, maybe she would choose not to be married. And again, in the broader arc of things, in the context of, you know, the case in Deaton reading, which points out the, you know, the deaths of despair, especially among white non-Hispanics, and it's not just men, but it's also women. But you might, you know, think about the labor market, you know, sort of contributions of men, and possibly explaining one of the things that they're saying is driving all of this, which is the decline in marriage. Let me leave it there. We are at time. Other questions? thanks again to everybody for submitting questions. I think that worked pretty well for this new world of Zoom in which we all find ourselves. You can continue to ask questions on Piazza, of course. Email will also work. Piazza is probably better because we can all weigh in together and see it. So in fact, I think at this point forward, I'm going to try to move all of our discussions onto Piazza. Okay. So it looks like maybe there are other questions that were submitted after 10:30 this morning. So I'll have a look at that and see what I can do. And okay, thank you to everyone. And I think I will sign out and I will post the video. Have a great weekend, a great rest of your Thursday.